So in this video, I'm going to give you some hints for tonight's homework assignment. So we have this first one, problem 32. Robert leans the lines that the right are perpendicular, which they totally appear to be. Mario's not convinced. You need to determine the slope of each line, so I put some dots on it. Like if we look at this line, we've got a dot right there and a dot right there, so that slope is negative 3 over 2. So the red one is negative 3 over 2. I'm going to leave you to do the other slope. So you'll want to put some dots on that. There's one there and one there. And then decide how you know whether the lines are perpendicular or not. Remember what has to happen with the slopes for that to be true. On this one, we want to write an expression for the perimeter. And perimeter is you add up all the sides. And don't forget about the two missing sides. So this one's 2x and this one's x plus 3. And so once you have an equation, so I'm going to go ahead and write that one down. We've got 2x plus x plus 3 plus 2x plus x plus 3, which combines to make 4, 5, 6x plus 6. So I've combined this and this to make 3, plus that makes 5, plus this makes 6, and then these two to get the other 6. And then in this problem, I'm not going to do this problem for you. It says if assuming that the perimeter is 78 centimeters, determine the dimensions. So that's 7 equals 78. Find x and plug in to those once you have it. And that's how you're going to finish that one. If we look at this one, oh, that's the same question. So sorry about that. I've put them together with the work we've already done. So on part C, it says verify that the area of the rectangle is 300 centimeters. So once you know what x is, we know the area is 2x times x plus 3. So if you plug in your two sides, whatever x is, it's going to be a fairly large number, and you plug it in and multiply them up, the two numbers that you get, you should get 360. So moving on to the next question. This one's a little weird because you've got figure 1, which has 2, 4, 6, 8, 10, 11 squares, 11 tiles. And then this picture, and I was really confused by this, but we've got 3, 7 is my picture. So now I have 2 points, 1, 11 and 3, 7, so I can find an equation. So I'm going to find the slope first. So my slope, my delta y over delta x. Delta y is from 11 to 7, that's down 4. And delta x is 1 to 3, so that's up 2. And so my slope is negative 4 over 2, which is negative 2. So there's my slope. And then I just need to figure out what's happening. So it's changing 2 tiles. It's decreasing by 2 tiles every time. So I could kind of build a table if you want. So I've got 1 and 3, and 1 is 11 and 3 is 7, and try to find the missing numbers. So what are these numbers? So and mostly I don't really need the 2, but I need the 0. And if I'm decreasing 2 tiles, between 11 and 7 is the number 9, and right here is 13. And so now I know my y-intercept, and this one I'm doing all the way for you because I felt it was a little confusing. Negative 2x plus 13. And so that is how we'd write our tile pattern. So a fairly crazy problem. Good luck with it. Oh wait, I gave you the answer. Then we have these two. Kitty's hog-nosed bat, or bumblebee bat, is one of the world's smallest mammals. It typically weighs about 2 times 10 to the negative 3 kilograms and has a 1.5 times 10 to the negative 1 wingspan. A giant golden crown flying fox bat, on the other hand, typically weighs 1.6 kilograms and has a wingspan of up to 1.7 meters. Estimate how many times heavier a flying boxing bat is than a bumblebee bat without using a calculator. So we're talking about the weights because we want to know how many times heavier. We're not talking about the wingspan, so we don't care about the wingspans. We only care about the weight. So my weight is 2 times 10 to the negative 3 kilograms, which is 2. We need to move the decimal 1, 2, 3 places, so 0.003 is what that is, kilograms. And then the typically weighs 1.6 kilograms is my other number. So 1.6 kilograms, they said not to use a calculator. And how many times heavier? So in other words, this number times something equals 1.6. So without a calculator, so what would I have to times by to get it? And so go ahead and see if you can figure that out. I would say since we had to multiply by, my guess is about 500. See what you think. Go ahead and try it. Now, question 36 is a little tricky. I'm just going to give you some general hints. For all of these, you need to change them into improper fractions. So we'll go ahead and change this one first. So we've got 9 times negative 7. 9 times 3 is negative 27. And this is supposed to be plus 2, but we have to remember that when it's a negative fraction, that's a negative 2 there. So it's going to be negative 29 over 9. And that is weird. It falls in one of the reasons I dislike mixed numbers, because of the implied plus, which in this case is an implied minus, which is very strange. And then over here we've got 72 plus 7, and 72 plus 7 is 79 over 9. And so when I add those two together, I get 50 over 9, and there's my final answer. I'm going to leave it there. I'm not going to turn back into a mixed number. Whereas B is a little harder because I do not have the same denominators. And I'm not going to do B all the way for you, but I am going to do some conversions for you. So 7 times 7 is 49, and then 2 makes 51, negative 51 over 7, minus, and then 20 and 1 is 21 over 5. And then there I am. I do not have the same denominator, so I have to get the same denominator. I'm going to multiply this one by 7 over 7, this one by 5 over 5, which will give me 5 times 51 is 255, minus 7 times 21, 147 over 35. I'm just going to double check my calculations on those, especially the 21 times 7. 147, and then 5 times 51. Okay, cool. I got both of those right. And so I said I was going to do this for you, so I'm going to stop now, and you can finish from there. With the multiplication, it's much easier. I'm going to go ahead and set up D. We are going to do the same thing where we do our switch first. So we've got 56 and 1 makes 57 over 7, and that's negative, divided by 45 times 5, so 50 over 9, negative. And remember, when we divide, we copy dot flip or keep change flip, whichever way you're using it. And so we've got negative 57 over 7 times 9 over negative 50. And I'm going to leave you there, and we can multiply straight across, and then this one we convert and then multiply straight across. So those are your hints for that problem. And then 37, which is our last problem, examine the figure graphed on the axis at the right. What happens if you rotate this figure 90, 45, 180? And all of those look exactly the same, but you can try it and see if I'm lying to you. What other angle could the right figure at the right be rotated so the shape does not appear to change? And see if you can come up with some other answers. What shape will stay the same no matter how many degrees it's rotated? That one is the perfectly symmetrical shape. It is this. So if you don't know what that is, then I'm sad for you. And I'm going to leave you to do this one. So good luck to you, and I will see you soon.